Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will try to perform flow correlation tuning using actual pressure data. Okay, so we will do the simulation within WellFlo software. We are now in WellFlo software. Okay, first by configuration and then model navigator, initialization, general data. You can input the information for company, platform, and so on and so forth. Okay. In my case, I will just leave it blank. Forward, and flow type, type producer, no artificial lift, flow type tubing, black oil, and it is a vertical well. Now we go to flow correlation. For the basis, we start from Hagedorn and Brown standard. Okay, this is important. Well and riser L factor is 1. Later on, we'll do tuning to adjust this correlation to match the actual pressure data. Okay, apply, and then we go to reference depths, well type onshore, 0 depth at calibushing to wellhead distance 20 feet. Okay, apply, and then we go to fluid parameters. Okay, I've prepared my data. You can follow me. You can also use your own data. Black oil, PVT calculation method, oil API gravity, oil specific gravity. I'm going to select inputting here, oil specific gravity, 0.85, so that the oil API gravity will be calculated. Okay, and then gas specific gravity, 0.65. Okay, water salinity, 30,000. And water gravity will be calculated accordingly. No inorganics. Okay, you can also open the PVT data calculator, input your pressure and temperature, and also produce GOR. And then you can perform calculation to obtain the fluid parameters. In our case, we can leave it blank. Okay, apply. You can also see if we are checked, it means that we can go forward. Now we go to forward reservoir. Okay, now we are in reservoir layers data. We can input data for our reservoir using layer parameters. In this case, you need to input permeability, thickness, wellbore radius, water cut, and GOR. You can also input manual. In this case, you need to provide the simulation with productivity index, or you can also input test data. In this case, you need to input test pressure and test rate. Okay, in our case, we select manual. The name of our reservoir is reservoir. Pressure, 6,000 psia. Temperature, 196. Mid-perf depth, 14,000. Water cut, 0.25 or 25%. Gas oil ratio of 500. Standard cubic feet per stock tank barrel. Okay. IPR model, we can select straight line, Vogel, Vetkovich. In our case, we select Vogel. Vogel coefficient 0.2, and our productivity index is 1.25, and our absolute open flow or maximum flow rate will be calculated. Okay, you can also see the IPR has been generated as per our information. Relative permeability, you can leave it as it is. Okay, we can go forward, apply, forward. Now we go to wellbore deviation, data type, MD TVD angle, enter data for MD, measured depth, and TVD, true vertical depth. We have a vertical well, so the measured depth will be equal with the true vertical depth. The bottom of our well will be located at 14,000 feet. Okay. Segment deviation from vertical, of course, 0 because it is a vertical well. Apply. Now we go to equipment. Okay, first we need to enter data for our tubing. We press add row. We call it tubing, starting from 20 to 13,000 feet. Okay, external diameter 3.5 with internal diameter of 2.992 inches and absolute roughness as per default 0.0012. Of course, it is a tubing flow. You can leave drift diameter blank. All right, and now we can input information for our casing. We have two sections of casing. We call it casing 1, starting from 20 to 13,000, just like our tubing, with external diameter of 7 inches, internal diameter of 6.3, with absolute roughness of 0.0012. And the next, casing 2, starting from the bottom of our first casing, 13,000, down to the lowest depth of our well, which is 14,000. The same external diameter, the same internal diameter, the same absolute roughness. All right, apply. Okay, so far so good. Forward. Now we can input our temperature model data. We can perform manual, calculated, coupled, or calibrated. In this case, we will select manual. So we need to provide this information, measure depth, and the temperature. I've prepared my data, so I'm just going to copy my data and paste the data here. We press add row. Okay, this is my data. You can follow my data also. Apply, forward. Okay, we have completed the data inputting. This is the dashboard. Okay, here in this separator icon, you can see fluid properties, oil API gravity, gas gravity, water gravity, PVT method, GOR, and water cut. And at the wellbore side, you can see well type producer, tubing flow, no artificial lift, right? Temperature model manual, no gas in annulus, well trajectory straight because it is a vertical well. And for well flow correlation, we select as a base case Hagedorn and Brown standard. And this is the reservoir information, reservoir pressure, the IPR model, we select Vogel, the temperature, productivity index, and absolute open flow. All right. Okay. Now from this configuration section, we go to tuning because we want to perform flow correlation tuning to finally select the best flow correlation. We go to tuning. All right. As you can see, this section is called match pressure surface. This is really important. We need to input our actual test data, name, survey, date. Okay, you can leave it as it is. And survey conditions, oil rate, let's say we obtain 1,325 stock tank barrel per day with produced gas rate of 0.65 MMSCF per day. Water rate 400 stock tank barrel per day. Okay, you can see total liquid rate will be calculated. Produced GOR, of course, will be calculated. And water cut also. Tubing head pressure or wellhead pressure 115. Wellhead temperature, it's actually optional, but we can input the data. 80 in our case. Oil gravity, it has been inputted gas gravity also, and water gravity using the information from our reservoir section. All right, and now this is the important part. We need to input pressure data in this survey data section. Okay, we can minimize this section. Okay, at row, I've prepared my pressure data, so I'm just going to copy my data and paste it here. Paste. All right. Apply. Okay. This is my data. You can see this is the measured depth, the true vertical depth, pressure, and temperature. You can select either MD or TVD. Okay. Now the data has been plotted. Pressure survey tuning, measured depth, temperature, the green dots, and the pressure data, the blue dots. All right, you can see the top data is around 100. The actual value is 115. Okay, and the lowest pressure, it's about 5,000. The actual value is 5,102. All right, this is the actual pressure and temperature data. Now we go to survey data correction. This data in this form has been changed. Do you want to apply the changes? Yes. Okay, now this is interesting. This is the survey data for our pressure. And this is the untuned pressure results from our selected correlation, which is Hagedorn and Brown standard, which means that the results from Hagedorn and Brown is not matched with our actual data. All right, they don't match. The difference is significant actually. That's why we need to perform pressure tuning or flow correlation tuning to select the best flow correlation. So it means that maybe Hagedorn and Brown is not the best correlation that we can apply. Or this L factor maybe need to be adjusted. Okay. So we go to flow correlation tuning. All right. Now we are in match pressure surface section. This window is important. So you need to familiarize yourself with this window. You can see this is the tune button. This section is for our correlations to be matched. And this is the plot. You can see the quality of your matching in this plot. Okay. First, we will select the correlations to be matched. We press add row. Okay. We can see the table. Okay, let's say we just want to try 3 correlations. The first one is Duns and Ross standard, and then Bex and Brill, and then Hagedorn and Brown. These 3 correlations are the most popular for oil well. You can skip these columns, MD change, deep well flow correlations, untuned RMS and tuned RMS. You can skip these columns for the time being and concentrate only on this one, tuned L factor. Okay. We now press tune. All right. The tuning has been completed. You can see the tuned L factor. Okay. And tuning status are successful. Okay, now we maximize the plot to see the quality of the matching. Okay. For now, uncheck the legend box. Okay. You can see the matching. First, uncheck the correlation. This is our actual data, the pressure and the temperature. Now we select only Duns and Ross correlation. You can see this is the correlation results if it is untuned, and this is the correlation result if tuned. By tuning, it means that the L factor has been adjusted from 1 to this value for Duns and Ross, 1.1993. Okay. So as you can see, the quality is quite good. And what about Bex and Brill? You can see the quality is not that good compared to Duns and Ross. Okay. Especially in this interval. And also, what about Hagedorn and Brown? Yeah, it's quite good, but actually the correlation from Duns and Ross gives the best matching. Okay. You can also now see the untuned RMS error and tuned RMS error. We of course prefer the lowest RMS error. And in this case, you can see Duns and Ross gives us the lowest RMS error, tuned RMS error. All right, so it means that the best correlation to be applied is Duns and Ross with this corresponding L factor, 1.1993. Okay, so that's how we select the best correlation. Okay, by tuning the L factor to obtain the best matching between our correlation and the actual data. Okay, now we tick this one to select it and then accept. This will replace the current L factor, which is 1 from Hagedorn and Brown. So we select yes, and you can see the note tuning result. The existing well and riser L factor, which is 1 previously, has been successfully replaced by the tuned value, which is 1.1993 in the model. The existing well riser, which is actually previously Hagedorn and Brown standard, flow correlation is also replaced with Duns and Ross standard. All right, so far so good. So we press OK. Okay, you can see again. Yes. Okay, you can leave it as it is. And let's see. In configuration, go to flow correlations. Now you can see the correlation has been adjusted to Duns and Ross standard with this corresponding L factor. All right, so far so good. Now we can perform nodal analysis. In this analysis section, okay, nodal analysis mode, analysis type, operating point, check the stability check, depth format, we select measure depth, and for the calculation nodes, top node, outlet node at the wellhead, let's say we select 165, the bottom node, of course, reservoir, solution node, casing, the lowest casing at the bottom hole, and now we set range. Okay, you can just click this one, auto range. Okay, press OK, press apply, and calculate. All right, so far so good. So the nodal analysis has been generated. The blue line is our IPR. The green one, of course, is our VLP with the best correlation, which is Duns and Ross with the L factor. Okay. Operating pressure, this is the results section. Operating pressure, liquid rate, oil rate, water rate, gas rate with the given water cut and produced GOR. All right, and also you can see the wellbore equipment profile to see the pressure profile from the bottom hole or from the reservoir, bottom hole, and wellhead. This is the temperature profile. And now we can also perform sensitivity analysis to see the results or the effects of flow correlation. Okay, so we go to sensitivity. We select this one, well and riser flow correlation. We select Duns and Ross, Bex and Brill, and Hagedorn and Brown. Okay, so we will do sensitivity analysis to compare these three correlations with L factor that we have, which is 1.1993. We press add. Okay, you can see manage sensitivity, well and riser flow correlation. We select for sensitivity 1, well and flow correlation. Okay, calculate, plot variable, sensitivity variables. Okay, we highlight all of them. Okay, we go to flow curves. Now you can see this is interesting. So each flow correlation will give us each VLP. So the VLPs will be different. Okay, from Duns and Rose, Bex and Brill, and also Hagedorn and Brown. That's why flow correlation tuning is really, really important. Okay, this is actually what we do in daily basis if we want to see or if we want to generate nodal analysis. Make sure you obtain actual pressure data. Make sure you select the best flow correlation based on tuning. Okay, of course, as what we did already, the best correlation is actually Duns and Rose. Okay, that's also in this video we have learned about performing nodal analysis, of course, and also performing flow correlation tuning, okay, to match the actual pressure data with our flow correlation results. And also we perform sensitivity analysis to assess the results from each flow correlation. Duns and Rose, Bex and Brill, and Hagedorn and Brown. Okay, that's all. I hope the video is useful. I hope you enjoyed the video. Thank you so much for watching. See you again in the next WellFlo videos. Thank you.